Okay, here's another problem involving parallel resistors. Now in this one you can see that we've got three resistors, R1, R2 and R3, and their values are 150 ohms, 200 ohms and 40 ohms respectively. So here's R1, here's R2 and here's R3. And what we want to do is work out the total effective resistance of those three resistors. So once again we're going to use our parallel resistance formula. So 1 over RT equals 1 over R1 plus 1 over R2. Now because there's three resistors, I need to now go 1 over R3. And if I had 4 or 5 resistors and these branched off, then I would have to keep going along and add 1 on R4 and 1 on R5. I can keep going as far as I need. Okay, so let's insert our values. So it'll be 1 on RT will equal 1 on 150 plus 1 on 200 plus 1 on 40. Now, this time I'm not going to find a common denominator. I'm going to just use decimals, convert these to decimals, which is probably something you might find a little bit easier at a pinch. So 1 over 150 as a decimal is 0.00667. So that will be 0.00667. 1 over 200 will be 0.0, that'll be 0.005. Yep, 0.05, that's right, 0.005. And 1 over 40, well, that'll be 0.025. Okay, so if we add those together, then we'll have 0.00667 plus it was 0.005 plus 0.025, and that equals 0.0367. 0.0367, that's rounding it up. And of course that is 1 over RT. So therefore RT over 1 will equal, and by the way, that you can put that over 1 if we like. So RT over 1 will equal 1 over 0.0367. So let's work out what that would be. That's 1 over 0.0367 0.0367, and the answer is 27.25 ohms. So that's approximately equal to 27.25 ohms. Now remember, that's an approximation because we did some rounding there, but that's the approximate effective resistance of those three resistors in parallel. Okay, in our next screencast we'll be looking at pardon me, resistor arrangements which have both parallel and series components in them. Okay?